Hi guys, I'm not there for today's lesson, so I thought I'd just make a quick video to explain what I'd like you to do. So just to recap what we looked at on Friday and last week, we were looking at straight line graphs, and we basically just did a recap, and we said that if you wanted to know the gradient or the slope of a straight line graph, what we can do is pick any 2 points on that straight line. We can look at the run, so the distance across from one point to the next. And we can look at the rise, which is the distance upwards from one point to the next. And that gradient or the slope is equal to rise over run, and most of you are very familiar with that idea. The other thing that we said, and this is the really important point, is that the gradient or the slope of that line is equal to the rate of change of that function. So the rate of change is really important in calculus. And so, for example, if this was a distance and time graph, the rate of change would be speed. So the gradient or the slope tells us the rate of change. And then we extended that into looking at a curved line. So this was on Friday. And we said that, well, because of the curves, the gradient is changing all the time. If you look at this curve, the gradient is quite low down here. And by the time it gets up here, it's quite high. The gradient's changing all the time. So if we're using that same method, all we can do is work out an average gradient. So if we pick 2 points again, say from here to here, that's not really a straight line in between, but we can still, look at the run and look at the rise, and we can say that the average gradient equals the rise over the run in this case. Now it's called the average gradient because it's a curved line. So the gradient, if we looked at this really closely, is actually changing as that curve goes along. So here it's, the rate at which it's increasing is lower, whereas as it moves here, that rate has just increased a little bit. So we're really only talking about the average gradient. And then we sort of looked at this and we said, well, if let's say we got these points closer and closer together, and kept measuring that average gradient, eventually, if we got really, really, really close together, we would have quite an accurate estimate of the gradient at a single point. So we sort of started to think, well, what is the gradient at a single point on the graph? And we said, well, if you got those 2 points really, really, really super close together, you would have a really accurate estimate of the gradient. And as it turns out, there is actually a nice little formula or a nice little idea for working out gradient at a point. So remember, up until now, we've only talked about gradient between 2 points. Now we're talking about the gradient at a point. We can actually say that's equal to the gradient of a tangent to that point. What do we mean by that? So we're not talking about tangent like in trig, although it's very, very much related. If we wanted to work out the gradient at this point here, if we drew a straight line that went through that point and just touched the curve, but didn't cross the curve, so that's this green line here, try to draw that as straight as possible, that is what we call a tangent. Okay, so if we wanted to know the gradient at this point, let's call it A, we could draw this tangent and then we could measure the gradient of the tangent. So we could measure, the run and the rise. Now we're back to our original definition of gradient. So if you can draw a tangent to a point, you can figure out the gradient at that point. So that's the key idea that you'll need for today's lesson. So what I want you to do is work on exercise 14B You can do all the questions from that. If you weren't here on Friday, you should also do exercise 14A2. And I want you to do question 1 and question 4. Now we're actually missing our double lesson this week, and you guys have a day off on Wednesday for course counselling. So I want you to make use of that time and finish any of these questions that you don't finish. So that's finish for homework. And in that time, probably tonight, I'll upload another video as well. So that will be Calculus 1.2. I want you to have watched that before next lesson. Okay? So this is what you need to be doing as preparation for the next lesson, because we're missing that double. Okay, thanks very much for watching. Have a good lesson today. Thanks. Bye.